Welcome to today's lesson on 8.5D. Our lesson target is I will use a trend line that approximates the linear relationship between bivariate sets of data to make predictions. Okay, so our main thing that we're doing today is making predictions, and we're using a trend line to do so. Approximates just means estimates. And then linear relationship, if we think back to what we learned about in our last lesson, when we have a trend line, the trend line can either be linear or nonlinear. So today we're focusing on just the linear associations, whether it's positive or negative. And bivariate, remember, just means two data sets, right? Because we have bi meaning two, varies or variables meaning two things that are being compared or that are changing. Okay, so then our essential question is, when given an equation, how can I find a missing x value when given a y value? Okay, so for example, if we have an equation y is equal to 5x plus 20, right? This question is basically asking what steps would we take if we're given a y value. So let's just say y is equal to 180. That's what the problem tells us. So if that's the case, then the first thing I need to do is I need to plug in the y value into the equation. So we have 180 is equal to 5x plus 20. And then from here, we're used to solving two-step equations. So then we would need to subtract. We would subtract the 20 on each side. And then from here, we'd get 160 is equal to 5x. From here, we'd go ahead and divide as our last step, right? But the first thing that we needed to do was plug in our y value. Okay, so now we have some vocabulary words we need to go over. Bivariate data is data for two variables, a dependent variable and independent variable that are related. So remember that x is our independent variable and y is our dependent variable. And the way that I always say to remember this is that y is after x in the alphabet. It's x, y, z. So that's why y depends on x. Okay, linear relationships. That's a straight line relationship between two variables. We've talked a lot this year about linear relationships. Then we have line of best fit. Line of best fit is a straight line that establishes a trend of scattered points that is used as a prediction tool. So line of best fit is going to be linear, right? Because it is a straight line. Then we have negative association. So negative association is when the value of one variable, usually y, tends to decrease as the value of the other variable, usually x, increases. So we have an example of negative association right here, negative linear association. So if we draw a trend line, so I'm going to go ahead and draw my trend line like this. You can see that it cuts through the points. It goes through most of the points. And you can see there's an even number of points above and below the trend line, or to the left and to the right of the trend line, however you want to think about it. So as you can see, as the x values increase, the y values decrease, right? Something that I wanted to point out, because I've been noticing students in class making this mistake, is they will draw a trend line, but their trend line will be like this, where this is not a good trend line because there's all these points underneath it, right? Or to the left of the trend line. Or they'll draw the trend line like this, which is the opposite, right? Where all the points are above the trend line or to the right of the trend line. Okay, so now we have no association. So as you can see, underneath negative linear association is our graph of no association. So we can't draw a trend line for this, right? Because the dots are kind of just scattered everywhere, all over the place. Then we have outliers. So outliers are a point that stands out from the data set because it is significantly different. So in these associations, there's no outliers. So I'm going to go ahead and just draw an example. An outlier would be if there's a point like that, or an outlier would be if there's a point like that, right? A point that's far away from the cluster of the other points. Then, of course, we have positive association. So positive association is right here. And if I were to draw my trend line, again, I'm trying to draw a trend line where there's the same amount of points, an equal amount of points above and below. You can see that it is positive because this line, this linear relationship, would have a positive slope. But also as the x value increases, the y value also increases. And then we have scatter plot. So a scatter plot is a set of points plotted on a coordinate plane. So all of these are examples of scatter plots. That's what we're working on. And lastly, trend line. So the trend line is a line on a graph that shows the association or the general direction between the data set. So this line of best fit for positive and negative is considered a trend line, but just know that this right here for nonlinear association is also considered a trend line. This is not considered a line of best fit because it is not a straight line. It is a line, it's a curved line. Okay, so now we have our activity. So for this first problem, it says Erica, who is an oceanographer, is measuring the temperature of the ocean at different depths. Her results are listed in the table. So as you can see, one of the variables that she's comparing is her depth in meters, and the other variable is her temperature in degrees Fahrenheit. So her independent variable is going to be depth, and her dependent variable is going to be temperature. So remember, X is for independent, Y is for dependent. Okay, so from here, we're going to go ahead and read A. A says create a scatter plot using the data Erica gathered for the ocean temperatures at different depths. So basically all we're doing is just plotting these points, right? We're graphing these points. Okay, so the first one is 176. So our graph is already labeled, right? Our temperatures are y-axis because temperature depends on the depth of water, our x-axis. So I'm gonna find my x value of 100 at the bottom right here along the x-axis, then I'm gonna go up to find 76. So this one is easy because 76 is actually labeled on here. Okay, the next one is 273. So I find 200 at the bottom on the x-axis, and I'm going to go to 73. So 73 is not listed on here. I see that it's in between 72 and 76. And if I look, I can see that between 72 and 76 is going to be 74, right? Because I noticed that I'm counting by twos. So 73 has to be in between that 72 and 74. So it's going to be right here. Then we have 370. So find 300, go all the way up to try to find 70. So right now 70 is not labeled, but I know that between 68 and 72 has to be 70 because again, I'm counting by twos. Then we have 466. So again, 66 is not labeled, but I know that 66 would be in between the 64 and 68. Then we have 561. So 61, of course, is not labeled because it's an odd number, and you can see only the even numbers are labeled. But between 60 and 64 is going to be 62, and obviously 61 is going to be below that. So it is going to be something like this. Then we have 656. And then we have 752. Then we have 848. And then we have 943. Okay, so 43 is obviously not labeled on here, but we know that in between 40 and 44 is 42. So 43 is going to be in between 42 and 44. Okay, so that is my scatter plot. And so B is asking me to explain the meaning of the point 400, 66, right? So 400 is our x coordinate, 66 is our y coordinate, and they are referring to this right here, this point right here. So basically, that point is telling us that at 400, we know 400 represents the depth in meters, right? So at 400 meters deep, we know that the y value represents the temperature. The temperature is 66 degrees, and we can see the unit is Fahrenheit. So it's 66 degrees Fahrenheit. Okay, C is asking what relationship does the scatter plot show between the depth of the ocean water and the temperature of the water? Okay, so when it's asking about a relationship, we have to think back to the associations that we talked about at the beginning. So I'm going to go ahead and draw my trend line if that's the case. Okay, so you can see through my trend line that it looks to be a linear association, right? So I'm going to say that there is and it looks to be a negative linear association because as the x value increases, the y value decreases. So there's a negative linear association between ocean or depth of ocean water and temperature. Okay, so then D is asking us to explain how there seems to be a linear association between the depth of the ocean water and the water temperature. Okay, so pretty much the same thing, right? We just said that there is a negative linear association. So we're going to say, being more specific, the depth of the ocean water is, or I can say there is a negative linear association, but is the depth of the ocean water has a negative linear association with the water temperature. Okay, lastly, E, it says describe the type of association that exists between the depth of the ocean water and the water temperature. We have to state the association in terms of the variables. Okay, so we're going to be more specific about what that negative linear association means, right? So as the depth of the water increases, the temperature in Fahrenheit decreases. And if I wanted to be more specific, I could say as the depth of the water in meters, right? Because that was the exact unit. Okay, so we're gonna skip this we do just because we already just graphed the scatter plot, and we're gonna work on this you do as we do. So this problem is saying that Angela recorded the price of different weights of several bulk grains. She made a scatter plot of her data. Based on the scatter plot, what is good prediction of the cost for 16 ounces of bulk grains? Okay, so if we look at this graph, we can see that we're comparing weight in ounces to price in dollars, right? So we have to first start by drawing a trend line, because anytime we are making a prediction on a scatter plot, we need to know what the association is. If it's positive, negative, linear, nonlinear, no association, right? So sometimes it takes me a few times to go ahead and draw a good trend line because I don't always get it exact. So I can see that in this line that I drew, I have 1, 2, 3, 4 dots above the line, 1, 2, 3, 4 dots below. So this one actually is an okay line. But if you need to draw it a few times just to make sure that your trend line is a good line, go ahead and do that. So for this problem, it gives us 16 ounces, right? 16 ounces. Ounces is our x-axis. So I'm going to find 16 right here. I'm going to go ahead and label it 16. So from here, I'm going to go ahead and draw a vertical line going up. And this relates to systems of equations when we learned about two lines that cross each other and meet at one point, because you can see that there's a meeting point right there. So once I find that meeting point or point of intersection, I'm going to go ahead and draw a horizontal line so I can see what is that equivalent y value, right? Or where is that on the y-axis? Okay, so I can see that it looks to be in between $1.20 and $1.40 or $1.60. So I know that it's going to be $1.40 because I noticed that I'm counting by twos again, right? So 1.2, 1.4, 1.6. So the best prediction for the price of 16 ounces of bulk grains is going to be $1.40 per ounce, or just $1.40 for the whole bulk. Okay, so most of the problems in this worksheet or in this lesson are going to be multiple choice. The difference is that sometimes you will actually have to draw a trend line. And I know that's where people mess up because, again, sometimes you're drawing a trend line that's, that looks like this, where all the points are below it. Other times you're drawing a trend line like this where all the points are above it. So make sure that you're drawing a good trend line, that there's an equal number of points above and below, where to the left and to the right of the trend line. Okay, so now we have our last set of we do, you do problems. So for this we do, it says the equation of the trend line is y equals 1 over 250x plus 200. So as you can see, this is a non-proportional relationship, right? Our slope is this 1 over 250. Our y-intercept is this 200. Anyways, it gives us an x value of 500. And it's asking what is the best estimate of the value of y, right? And then this little hint here says you can substitute 500 into the equation. So it's telling us to substitute, to plug back in the 500 into the equation. So that's what I'm going to do. I have y is equal to 1 over 250 x plus 200. But instead of writing the x, I'm going to plug it back into the equation. So I know my x is 500. So I'm going to go ahead and put that in here. Yes, I can use Desmos, type this in, solve it. But because this is easy math, I'm going to go ahead and do it, right? So when we have a fraction, we know that that's the same thing as division. And so I'm going to multiply the 500 times 1, which is 500. And then on the bottom, I'm going to keep my denominator, which is 250. So we have 500 divided by 250 plus 200. To simplify this division problem, I'm going to get rid of the zeros on top and bottom. So I can only cross out zeros if they're on top and bottom and not in decimals in numbers. So I'm just simplifying fractions essentially. Okay, so from here, we have y is equal to 50 divided by 25 is just 2. And then we have 2 plus 200 is going to be 202. So of course, our answer is going to be G, 202. So the rest of the worksheet, again, is making predictions. Some of the problems will give you a trend line. Some of the problems you have to draw your trend line. Thank you so much for following along in today's lesson, and see you in the next one.